All right, looking at the second page of the Chapter 4 test, we're asked to solve for x. As I look at this, I can see that I have a factor of 2 in my denominator. I can also see that there is a factor of x. In fact, two of my denominators have factors of x. This is going to require two factors of 2, right? This is a 2 times another 2. So I'm looking at the single value. I choose to look at the single value that will eliminate all the fractions in one step. In this case, the value that would do that would be 4x. So I'm going to choose to multiply both sides of this equation by 4x over 1, right? So I'm just pushing a 4x across all the factors on the left-hand side and the single factor on the right-hand side. Every single one's going to get a factor of 4x. And then I'll just simplify that fraction. If I wanted to, I could multiply everything by 2 and then see what happens. Then multiply everything by x and see what happens. And then by the time you get there, you're going to realize, oh, I still need one more factor of 2 to eliminate all the fractions. So if I just write this, I'm going to just write the 5 from the original problem times 4x over 2x. So I'm just copying these parts. That's the first part. And then I've got this minus 4 times 4x over a factor of x. Just copied that part. And that's going to equal 15 times 4x over 4. So you can see I very, very carefully just brought in factors of 4x and placed them in every single one of the numerators of the original equation. And I'm allowed to do that because if you have equal things and you multiply both sides by an equal thing, you get equal things. So what I'm multiplying both sides by here is 4 times x, and it gives me an equivalent equation. So the upside of this is there's a lot of things that I can simplify now, and that's the reason why I did that. One of the things I can see is that there's definitely a common factor of x over x here. This also has a common factor of x over x. This has a common factor of 4 over 4. And the other thing that I have is this 4 is 2 times a 2, so I have this giant one that's a 2 over a 2, but I'm left with an extra factor of 2, so let's not forget that. So if I just go through now and kind of look at each one of the parts and rewrite them, I'm left with, let's see, 2 times 5 in the numerator, which is the number 10, minus, that looks like the number 16, and that equals 15 x. Well, 10 minus 16 is negative 6, so this equation becomes negative 6 equals 15x, and if I divide both sides of that by 15, I get something equivalent to x is negative 6 over 15, right? Negative 6/15. There is a common factor there. Both of those can be divided by 3. You can see that by writing it, if you wanted to, as 3 times, I might put negative 2 over 3 times 5. So yeah, 3 times negative 2 is negative 6, and 3 times 5 is 15. So the value that I would write down for x, I would say that x is negative 2/5. All right, let's move on to the next question on this page. I think it's question 4. I think 4 had three parts. It says, write the equation of each line described below. The first one says, a line with a slope of negative 2 and a y-intercept of 7. That's fabulous. We know the slope and we know the y-intercept. So if our slope is negative 2, I'm just going to plug that in for the slope, right? Y equals negative 2. Nope, not. Negative 2 times x. And we know our y-intercept is at plus 7, right? When x is 0, y is 7. So this is our first equation. The next sentence says, find the equation of a line with a slope of negative 3/2 and an x-intercept of 4, 0. So this is not my y-intercept. I can't just simply plug it in like I did above when I knew the y-intercept. I've got to figure out what my y-intercept is. So I'm going to write the equation y equals negative 3/2 times x and then plus b. I don't know what b is, but I'm going to figure it out by using the point that I was given, right? The point that I was given was There's an x and a y value here. I'm given that y is 0, so I'll write 0 equals negative 3 halves times x, and x was 4, and then plus b. Well, if I was to simplify this expression, negative 3 times 4 is 12, and half of that is negative 6. So this equation becomes 0 equals negative 6 plus b. So 6 is what b is. So now I know that my y-intercept occurred at 6. Now we can write the equation of that line. It's going to be y equals negative 3 halves x, and then plus the number 6. So that's our equation for part B. And then finally, part C says find the equation of a line perpendicular to the line in part B. So two things here, perpendicular and to part B. So remember, whenever we rotate the entire Cartesian coordinate plane 90 degrees, and it doesn't really matter if I go counterclockwise in this case, what happens is my rise and run switch places, and if I've got negative slopes, they become positive, and positive slopes become negative, right? So there's two things that we think about. It's the opposite in sign, and it's the reciprocal, and we've visualized this a lot in class. So if I have a slope of negative 3 halves, that means 2/3 is the slope that I would need down here. So this 2/3 is the slope of a line that would be perpendicular to a line with a slope of negative 3 halves. So that's the first thing. It has to be perpendicular. The other thing is I'm going to use this x and this y to figure out the y-intercept. So the y value is 0, and the x value is the number 4. And I'm going to have my plus b. So if I do that, 2 times 4 is 8/3 plus b is 0. And if I take away 8/3 from both sides, I get negative 8/3 is what b is. So I now know my slope, right? My slope is 2/3, and I know my y-intercept is negative 8/3. So I can write down the equation of that line. The equation of that line would be y equals 2/3 times x, and then minus 8/3. And that line would do two things, right? When I plug in 4, 0, when I plug in 4, it's going to produce an output of 0, and that line is perpendicular to the one from part B. All right, so let's move on to, I think, the final question on this page. No, there's two more questions on this page. Let's move on to question 5. It says, find each product, use a generic area model if needed. So I just generally recommend generic area models for now. We may not always need them, but they're certainly helpful now. So for A, I guess I'm going to do 2 by 3. The reason why I'm doing 2 by 3 is I can see that my first factor here has 1, 2 terms, and then my next one, the next factor, the next thing I'm multiplying, has 1, 2, 3 terms. So I could write, for example, A and then 7. This is a generic area model. And then across the top I could write I've got an A squared, I've got a 2 times A, and I've got a positive 5. So the goal here is to figure out the area of each one of these pieces by multiplying their individual lengths and widths, and then combining the like terms. So in the first case, this upper left box, I've got an A times an A squared. Well, A times AA is A to the third power. It's AAA. The next box over to the right, I've got a 2A times another A, which would be 2 times A squared. And then my final box in the top row, I have a 5 times A, which is just 5A. Let's go down to the second row. I've got 7 times A squared, which is exactly 7 times A squared. And then I've got a 7 times 2A, which would be 14A. And then finally I have 7 times 5, which is 35. So two sets of these boxes have like terms in them. I can combine them. I can definitely combine the 2A squared with the 7A squared. And I can also combine this 5A with the 14A. So the answer that I'm looking for here is, this is fully simplified, is A to the third power plus 7, 8, 9, 9 times A squared, and then plus 14 times, or 14A plus 5 more A is 19A A. And these are A's that are being added, right? You've got 14 of them, and then plus 5 more is 19 A's. And then finally, I've got plus 35 A's. So this is my answer for 5A. And let's go ahead and do 5B, our last question here. Second to last question on this page. On this one, I'm squaring x plus 6. And a common error is just to say the answer is x squared plus 36, but that misses important parts of that product. So again, a generic area model helps me see all of those parts. So I'm going to use the area model. This length is x units long, and then this is 6 units long, x units long, and 6 units long. So there's my generic area model, and the parts that go in it would be, I've got an x squared, I've got a 6 times x, I've got a 6 times x, and then 6 times 6 is 36. So the part perhaps you might have missed is the fact that there's this 6x plus another 6x. So in total we have x squared plus 12x and then plus 36. So this is the trinomial that I get when I square x plus 6. That is x plus 6 times another x plus 6. And then my final question is, it says, what number is not part of the domain of this function? And the idea here is, what value can I not place into that? And there's really only two things that we've talked about in class and we've been looking at. Division by 0 is undefined, and that's what applies here. Another thing that applies is that because we're restricted to the real number system, square roots of negative numbers are not allowed. So in this case, what I need to make sure that this is never 0. So in order to make sure it's never 0, I'm going to do the maybe counterintuitive thing of taking x minus 1 and setting it equal to 0 and solving, and it tells me 1. So what this means is that x could be anything I want it to be, except it can't be 1, because the moment I place a 1 in here, right, I end up getting 1 minus 1, which is 0, and I don't care what the numerator is. Anything divided by 0 is undefined. So the restriction here, what was the question? It's the screen now. Anyways, it says state the domain of the function. I think it would be, what we're going to write for our answers is all real numbers with the exception, with the, OneNote is not being happy with me right now. With the all reals, let's see, all reals except 1. I can't write on this right now. All reals except 1. So you hear me saying it, that's what I intend for us to write down. Anyways, that's it for page number 2.